Creating a research poster from a scientific paper could take hours, if not days. But what if AI can take your paper as input and generate a publication ready poster design template as output? So, this paper titled Paper to Poster from NeurIPS 2025 claims that it can just take in a paper and output a publication ready poster. Let's see how real that claim is. So, welcome to the series on decoding papers with AI, where we take in a scientific paper and try to use AI tools to decode that paper and try to understand what that paper is all about. Let's jump right in. So the first AI tool that we're going to use is Saral AI, and it's accessible at saral.democratizeresearch.in. The first step is click on Saralify, and which will ask you to just log in. So here's the place where you can upload a PDF document or an archive link, and I've just downloaded the PDF, so I'm going to just upload the paper to poster PDF. And my favorite one here is One Click Podcast. So it takes in a paper and then it creates a podcast. The funny way, there is also One Click Poster here. So this also perhaps uses some methods from the paper that we're going to discuss, paper to poster. So let me click on One Click Podcast and then generate English. This could take a while. So what we're going to do in the meantime is that when as it's generating, let's look at the project page, right? So this is paper to poster towards multimodal poster automation from scientific papers, and this was published at NeurIPS 2025 DNB, and the authors are from University of Waterloo, University of Oxford, and Vector Institute. So they also have a code, they provide data sets, and they also provide a Hugging Face demo. And here is a very nice paper to poster, the output for this paper itself, right? So that's pretty cool that they're actually like showing that. So here is TLDR. So we address how to create a poster from a paper and how to evaluate that poster that is being generated. So basically, here's a paper, and here is the poster created by an AI agent called the poster agent, and here is a poster created by an author. So the question is, how do you evaluate if the AI agent's poster how it compares to the author's poster and so on, right? So they've given a few more examples on they've taken different posters and then they've converted them to different papers and converted them to posters and used different uh, large language models, and then they show how their method works, and then they show a few examples and so on. So you hear many examples of what their output is. So that's very nice. And here is also the paper, the actual paper. It's reasonably, although it's single column, it's about 50 pages. So it's pretty long. So what we'll do is let's see if the podcast is done. And yeah, the podcast is done. It was done quite a while back, I guess. So it has generated a 3.5 minute podcast for this paper called Paper to Poster. So let's just play it and see what it says.
Hey Rohan, ready to dive into this PAP, ER2, POS, TR thing? Sounds wild. Totally. Automated scientific posters? Sign me up. Where do we even start? Okay, so the problem is making research posters is hard condensing everything. Right? It's like squeezing an elephant into a teacup. Exactly. And apparently, current AI isn't great at it. This paper aims to fix that. So, what's their approach? Do they just throw GPT 4.0 at the problem? They do initially. But GPT 4.0, while visually appealing, messes up the text. So, noisy text, like scientific jargon soup? Worse, incoherent, and it fails at that paper quiz thing. Paper quiz? Sounds painful. What is it? It tests if the poster actually conveys the paper's key points. VLMS take the quiz. So AI judging AI. I love it. Clever, right? So their solution is this poster agent system or pipeline. Pipeline, okay, break it down for me. What are the stages? Three main parts: parser, planner, and painter commenter. Parser first, what does it parse? Paper, obviously, but how? It picks the paper PDF and creates a library of text summaries and figures. Okay, so it's extracting the important bits like a research digest? Precisely. Then the planner comes in. And plans? What's the plan, Stan? It matches the text summaries with the right visuals and creates a layout. A layout like deciding where everything goes on the poster? Bingo! Using a binary tree layout, apparently, to keep things balanced. Fancy. And painter commenter? Sounds like an art class critique. Almost. The painter renders each panel using code, then the commenter comments? Harshri, I hope. Using a VLM, it gives feedback to fix text overflow and alignment. So, visual feedback is key. That's what GPT 4.0 was missing. Exactly. It's a visual in the loop system. Iterative refinement. Makes sense. And does it actually work better than GPT 4.0? Yes. Their open source version outperforms GPT 4.0 on most metrics. Wow. And uses fewer tokens? That's efficient. 87% fewer, they claim. Plus, it's cheap like 0.005 US dollars per poster. Okay, that's insane. So, posters on demand for pennies? Pretty much. They've even open sourced everything. That's awesome. Reproducibility is so important. Agreed. So, automated poster generation, a real possibility now? Seems like it. This PAPER2 POSTER benchmark could really push the field forward. Definitely. It's exciting to see AI helping researchers communicate better. Agreed. Who knew making posters could be so cutting edge?
So that was it. That was cool and fast. And it's interesting to see that it has something called paper quiz, which is used to judge how the paper poster has come out and so on. So that was nice to just quickly get an overview of what this is all about. And they think it mentioned that there are three agents, right? One is a parser, which is going to take all the images and the text and so all the other things, and from the paper. And then the second one is a planner, which tries to plan how to make use of all of this if it wants to like generate it in a poster. And then I think there's one more or two more, like one that actually generates these poster, and then the next one which is going to kind of a critique, which is going to like critique and say how is this generated poster, and it's going to refine it till it gets a good state. That was my understanding from what this whole podcast was about. But let's maybe use a couple of more AI tools to find out if that's true or not. So the next format I'm going to try is I'm going to make it very interesting here. So we're doing paper to poster. So why not we use Saral's version of paper to poster, which is kind of a maybe a forked version from this original paper, and see what it provides. So we're going to do a paper to poster for the paper to poster paper, just like how the authors had done it for themselves. I think Saral's version, if I'm not wrong, kind of was inspired by this paper, but it slightly like generates it a little faster and uses less computations. And the other thing is that as of now, maybe images are not there yet, but so you cannot compare like apples to apples, this version and the paper to poster version. But I think like still it tries to just generate a quick summary in a poster format for the paper that is there. So let's see if it's able to like quickly generate something, and then find out. Okay, it's done. So let's download the poster and we're just gonna open it. Okay, I was wrong. I think it generates photos. That's very nice. Um, so it has all of these here: paper to poster, a visual in the loop multi-agent framework for automatic scientific poster generation, and it says academic poster generation is a complex task. So this work introduces paper to poster, the comprehensive benchmark and metric suite, a long poster agent, a top-down multi-agent pipeline that automates transition from PDF to editable poster. So they've done it, evaluated with GPT-4o and vision language models. So here's just an introduction, which we know why, and then here's the methodology. Um, it introduces the paper quiz metric, which uses vision language models to simulate reader comprehension through multiple choice questions derived from the source paper. The poster agent utilizes a parser to distill document PDFs into structured asset libraries and a planner to organize this into balanced like binary tree layouts. A painter commenter loop, iterative. So this is like a GAN, iteratively like generates and then discriminates and then tries to like kind of do a back and forth till it gets a very good poster that is generated. So yeah, here is the input and here is the dockling and all of those things and key value and then so many things there. So Saral uses many of these. Saral was, I think, later on inspired by this work, and many of the same libraries are also used here. So, in conclusion, the paper to poster benchmark. So let's see, paper poster agent variants based on open source models. Like, so the system achieves a 14x textual compression using the paper quiz and 87% compared to existing multi-agent. So the conclusion, the paper to poster benchmark provides a rigorous framework for evaluating next generation of automated scientific communication tools. That is amazing. And then demonstrates a vision in the loop, multi-agent design, effective and efficient for complex layout tasks. Future work will focus on integrating external community feedback and enabling human AI collaboration. So that's pretty cool. So I think the poster version of Paper to Poster was also pretty cool and gave us a quick overview of the entire pipeline for this work. So for the last part of understanding paper to poster, so I'm using Notebook LM and it's recently introduced really amazing feature called cinematic video overviews. So taking a paper and generating a cinematic feature film like animations for the paper, and this has generated one which is like 9 minutes long. So that is like pretty cool. So let's just see what it's about.
Academic conferences require researchers to compress months of work, often 20 pages of dense text, charts, and equations, into a single, tightly bound page. A viewer walking past has about 3 minutes to grasp the core insights. For an automated system, this requires multimodal context compression. Standard text summarization simply cuts words to hit a target length. This process requires preserving the core logic, maintaining the integrity of data visualizations, and locking both into a strictly confined two-dimensional grid. This chart maps token counts across source documents versus final outputs. Inputs routinely exceed 20,000 tokens. These must be distilled to fit the narrow red spike. But standard language models process information in linear streams, lacking any native understanding of physical dimension. Without an explicit visual feedback loop, an LLM cannot calculate a spatial bounding box. If you ask a text-based model to arrange paragraphs and images on a single canvas, the layout collapses. Text overflows the designated margins, or the system leaves massive, awkward blank spaces. To evaluate and solve this exact spatial reasoning deficit, researchers built the Paper2Poster benchmark and a specific multi-agent framework called Poster Agent. Text generation is solved. The immediate engineering hurdle for artificial intelligence is forcing linear text models to reason about and generate structured 2D spatial layouts. Before building a system to design layouts, we must establish a rigorous way to score them. Evaluating visual design usually defaults to subjective human preference, which is impossible to optimize algorithmically. We strip away the subjectivity by focusing entirely on utility. An academic poster exists for one distinct function: to transfer a dense set of specific facts from the source material into the brain of the reader as quickly as possible. The researchers developed an evaluation metric called paper quiz. An examiner LLM ingests the original source paper and generates 100 specific multiple choice questions. Half of these test verbatim facts, and the other half target high-level conceptual comprehension.
So this is really cool because this can be used for any, say, even like to find out if a large language model is hallucinating and so on. Especially for systems that take papers and convert it to a different format. This type of simple like multiple choice questions is really useful. It can also be like you'll also know exactly which one went wrong because since it's multiple choice, there's no ambiguity here. That's pretty nice to see that. And I've been liking so far what it's telling. Like, so my understanding is that it try the layout. and text can overflow outside the layout. So like how do you kind of um, optimize or pick something wherein you have a good layout and the text also is within the layout. So if you've seen the previous two posters that were generated, maybe it didn't appear to me before seeing this video, but now I see, after seeing this, it appears to me that it occurs to me that there are some clear layouts and the text does not overflow. So that was pretty cool thing, and it's not happening just by like by luck or something. It's happening purely by design.
The grading mechanism completely isolates the text. The system forces a vision language model to take this 100-question test using only the pixel data from the generated poster. It cannot read the source paper. To simulate a real conference floor, the benchmark deploys 6 different vision language models. By using small open source models as a baseline and highly capable models like O3 at the top end, the system perfectly mirrors a human audience, ranging from casual students to expert professors. When a model correctly answers a high volume of these highly specific questions, it provides a mathematical baseline. It proves the layout successfully compressed and transferred the original knowledge.
Yeah, so this is what I was referring to earlier. Like maybe this is something which it did not occur to me before I saw this video. Is that because I was always thinking of, okay, taking a paper, converting it to a poster, and then how do you just evaluate this poster with a human made poster? And that's what the paper quiz is trying to do. But what it's also important is that even when generating the poster, it's really important that you have really good layouts, and then the text should be like inserted or generated inside those layouts in the right form, in the right format, and in the right font size, and even the right amount of text. So it should not really like overflow beyond that. So those are all important things, and I think this paper also talks about that. That's really nice to know that.
Rendering subjective aesthetic critiques irrelevant. But visual execution still dictates the speed of information transfer. Severe formatting failures, like overlapping bullet points, microscopic font sizes, or misaligned charts, destroy basic readability and prevent the reader from absorbing the data. To measure this, the benchmark utilizes a holistic assessment. A VLM acts as an automated judge, scoring the finalized layout on a strict 1 to 5 scale across 2 distinct categories: aesthetics and information. The aesthetic score is split into element quality, layout balance, and engagement. It measures the spacing of text and graphics, checking for visual harmony and ensuring there are no inferential leaps required to navigate the slide.
That's pretty cool. This is quite amazing to see that there are these like the aesthetics is not just like saying, okay, or just giving a number, but it is actually like very scientifically measured using three different parameters. That's really nice.
The most critical failure point for generalized AI is engagement. This tracks color, typography, and visual momentum. When left to their own devices, unspecialized models generate overly busy or extremely dull designs that fail to hold a viewer's attention. The information score is evaluated through clarity, content completeness, and logical flow. The judge explicitly checks if the timeline of the research tracks correctly from introduction to conclusion, penalizing the score for any missing core variables. By isolating a poster's visual execution from its logical structure, engineers can diagnose exact failure states. If a model scores high on logical flow but fails layout balance, the pipeline requires spatial tuning, not better text summarization. The poster agent architecture solves these layout failures by enforcing a strict top-down philosophy. It completely separates the global document mapping phase from the localized pixel rendering phase. The process begins with the Parser agent. It ingests the raw 20,000 token PDF and computationally strips it down. It outputs a highly structured asset library, isolating distinct section headings and building a condensed paragraph-level synopsis for each. Simultaneously, the parser identifies and extracts every figure, table, and caption. It isolates the visual evidence from the textual narrative, treating them as independent assets to be placed later. The compiled
So I really like this figure. We spoke about assets, and in the first agent, which tries to get all the text and the figures from a paper. So this is very neatly like explained that you see text on one hand, and that's also divided into probably like different sections, and then you have all the figures on this side. So it's also nice to see how it is actually like put all of this together and differentiates this in a very nice way as what the assets could be. And also, like a tiny detail I'm just noticing is that I don't think any of these are even similar, so they're all different. That's also a small detail, but nice to see.
Sets to be placed later. The compiled library is then handed to the planner agent. The planner semantically analyzes the condensed text synopses and explicitly matches them to their corresponding visual charts. It then constructs a binary tree layout. By estimating the required token length for each matched text and image pair, the planner dynamically allocates specific dimensions for each panel on a grid, locking in the spatial balance before a single pixel is drawn. Mapping the entire document into this mathematical tree structure eliminates massive context windows. The core language model never has to hold the entire layout in its memory at once, preventing it from losing spatial orientation. Even with a perfectly calculated global map, rendering the actual presentation invariably fails on the first pass. Text formatting introduces unpredictable micro-overlaps that a mathematical grid cannot foresee. To handle the actual generation, Poster Agent initiates the Painter agent. The Painter takes the paired textual and visual assets for a single panel and distills the text into hyper-concise bullet points. The Painter does not stop at text. It utilizes the Python PPTX library to output highly specific, executable code. It effectively forces a draft presentation slide into existence through programming logic. The moment the draft panel renders, the system introduces the commenter agent. The commenter acts as an independent oversight mechanism, running a direct visual inspection of the painter's rendered output. The commenter utilizes a focused zoom-in strategy. It crops its vision exclusively to the specific panel bounds and compares the spacing against highly refined in-context reference examples of ideal layouts. The system specifically scans for spatial breakdown. The commenter determines if text is overflowing the rigid boundaries, if the bullet points are too dense, or if there is awkward, unbalanced negative space.
So this is what I was mentioning earlier. So it's great to see that there is actually a commenter agent which actually tries to pick on all of these, overflow and other issues as well.
The commenter logs these errors and issues direct spatial adjustment instructions back to the painter. The painter ingests the feedback and rewrites the Python code to adjust font sizes or reposition visual assets. This tight feedback loop iterates continuously. Draft, scan, adjust, redraft. It repeats at machine speed until the commenter signals that the layout perfectly respects the mathematical boundaries. This visual in the loop mechanism bridges the gap between text prediction and design. By verifying the execution with simulated eyesight, the system reliably formats complex physical space. We can measure the success of this architecture by comparing the finalized poster agent output directly against a zero-shot attempt from a proprietary generalized model like GPT-4o. Generalized models often fall into what engineers consider an aesthetic trap. A standard 4.0 output looks visually striking at first glance, but close inspection reveals catastrophic errors. The text is noisy and hallucinated, and the logical flow of the original paper is abandoned for the sake of graphic design.
So I've seen this so many times. The text is so bad, it gets messed up. Even today, it's become a lot better. But many times, anything, if you want in an image with text, that's not the, it's always been an issue.
This chart displays average paper quiz scores. The purple poster agent line consistently outperforms the green GPT-4o line across all models. Notably, on the far right, the O3 model evaluating poster agent scores higher than reading the original paper, proving structured layouts improve comprehension. Beyond accuracy, the multi-agent framework reduces overhead. Because the tasks are highly specialized, an entirely open-source instance can ingest a 22-page academic paper and render a fully editable slide deck while using 87% fewer tokens. The total cost is half a cent. By actively compartmentalizing text extraction, executable code generation, and direct visual critique into isolated nodes, we force the software out of the realm of abstract text generation. We are building systems that can accurately format the physical world at near zero inference cost.
Amazing video as always. Some visuals like these and some of the previous ones that we saw, how clearly, along with the audio, illustrates this paper. So it's nice to know that And maybe so that's it with this chapter. Hope you enjoyed reading the paper to poster using AI tools like Saral AI and NotebookLM. So until the next one, where we go into another paper. So, all right, bye.